Okay, so we'll start. Okay, so the last class, what we have covered, first we're gonna have the quick revision on those topics. Okay, so yes, the very first class, what we have covered is what is DevOps and why DevOps. What is DevOps and why DevOps? This was two topics that we have covered in class 1. Okay, and in class 2 we have seen how to introduce yourself as an AWS DevOps engineer, right? And then we have seen what are the day to day activities. What are the day to day activities that you have to mention as a DevOps engineer in an interview, right? And apart from this, we have seen like what is the myths about DevOps. That means what are the rumors about DevOps. And even we have covered DevOps history, in which year DevOps has been evolved and who was the person behind the creation of DevOps, right? And we have covered why organizations needs DevOps engineer or DevOps specialist, right? And then we have seen what is SDLC, and even we have covered types of SDLC. Okay, so let's start a quick recap. Okay, so what is DevOps? DevOps is the combination of two words. What is that word? The first one, development team, and the other is operations. Development plus operations equals to DevOps. Okay, so it is a culture. DevOps is not a tool. So never ever mention in an interview that if you're attending any interview, do not define that DevOps is a tool. DevOps is a culture. DevOps is the approach, right, to promote the development and operations process collectively. Okay, in short, DevOps is an approach or culture that improves delivery. What delivery we are talking about? We are talking about software delivery, right? Because in an IT company, what delivery we do? We provide service delivery, software delivery. Okay, so then, like any person who do not have any idea about IT company or IT jargons, IT technical terms, so they can ask what is development team. So development team is nothing a group of builders who create program, computer program, or you can call coding or application. So they have different roles, like the architect who plan how everything will work, the builders who gonna write the code, and the tester who make sure that everything is working fine. Okay, so that means development team is not a single set of people. No, development team is a set of people. What is the first people? Architect. The first people, architect. You can see the architect who plan how everything will work. Okay, that means planning part will be done. Who gonna do the planning part? The company head. Your, it may be CEO, it may be CTO, it may be business analyst, right? Or any of the company head members, right? They will sit, they will discuss, and they will have the planning, right? And then after this, after the planning part, okay, after the planning part, okay, there will be one more team known as builders or known as developers who will be writing the code. Okay, and apart from the code, once the code has been written, there will be one more team that is known as testers who gonna test the code, right? So you can see tester who make sure everything is working correctly. There are also people who make sure the program looks good and it is easy to use. That means the application what you are designing, it is user friendly. It should be user friendly. So there will be, apart from this, there will be, just a second. Yeah. So apart from this, there will be one more set of people who gonna look after the designing part, or you can tell QA, that is quality assurance team. They're gonna check the quality of the software, quality of the application, right? Yeah. So you can see this is all about development team. This is all about development team. Now coming to operations team. What is operations team? So operations team is nothing, it's just like a maintenance crew. That means they are the heroes behind the scene. They are the heroes behind the scene. That means what they do, they make sure the programs and systems keep running smoothly. This team handles things like setting up servers, managing database, making sure the network is working well, and the most important, they make sure that keeping everything secure, right? Keeping everything secure means they will take care about security also. So suppose if you go for flipkart.com, and if like you got a project, you got a proposal, your team got a project or proposal to create a website just like a Flipkart, right? So you can see first planning will be done. The first phase will be planning. Okay, so planning means it's a architect. So, what are the phases? Phases involved in SDLC. What is SDLC? SDLC, software development life cycle. Okay, so it just like, suppose if you are planning to bake a cake, right? So if you are planning to bake a cake, the first thing what you're gonna do, you're gonna look for the ingredients, right? You will start collecting all the ingredients, right? And then after collection of ingredients, you gonna start baking the cake, right? Similarly, in software development life cycle, the name itself tells software development life cycle. What is this? Okay, so in an organization working as a developer, tester, or DevOps engineer, everyone has to understand the whole flow or the whole process of delivery, software delivery, right? That means similarly like a recipe for making a cake, so it gives you a step by step instruction how to go ahead, right? Similarly, SDLC is like a set of instruction for building the software. It's a set of instruction, or you can call it's a process how software will be built. Okay, so the very first phase will be planning. The very first phase will be planning. Planning will be done by whom? I told CTO, CEO, or business analyst, or the company head. Okay, so once they have received the project, right, first they're gonna do planning. Okay, planning means here gathering of requirement. They will have the discussion, they will have the meet, and they will discuss. They will ask the client that what are the things they are looking for. Okay, so you can see this is the Flipkart website. This has so many catalogs: grocery, mobiles, fashion, electronics, right? So we will ask in the same manner, like how many features you want to involve in your website, like what the sections should be like, become a seller, sign in, cart, login, everything, right? So we will ask about each and every requirement, right? So this is it's a gathering of requirement, or you can call it as a discussion. Once the discussion has been done, once the discussion has been done, the second phase will be code phase. What is this? Developer will start writing the code. Developer writes the code. Okay, the third one, once the code has been written, once the code has been written, here server admin or system admin, they will launch server, or you can call, like I'm talking about the manual, like earlier process, traditional process, right? Like before 10 years ago. Okay, so before 10 years ago, right now also the process is same, the steps are same, just the difference is right now every steps we have automated. Earlier it used to be a manual approach, right now it is fully automation. Okay, we're gonna see the difference. Okay, so now you can see planning, the code has been written, and now server admin or system admin will create the server, will create the server. Okay, and deploy the code there. On the server they will deploy the code. Now tester will start testing the code. Tester will start testing the code. Once everything is verified, now build and release engineer comes. Build and release engineer, what they will do, they will deploy the code. They will deploy the code, or you can call application that you have built. They will deploy the code or application in pre-production area. In pre-production area, or they can finally deploy in production area. In production, not area, we call it as production environment. Okay, that means we will deliver once everything is okay. We have checked in pre-production environment, everything is good. Now we can finally release this application for the end user, like this, right? So that user will be able to access my website, or user will be able to install that particular application. Okay, now once deployment has done in production environment, then there will be a team who will be doing monitoring, and if any bugs come, there will be a team who gonna look, or who gonna take care of the maintenance, right? So this is the normal phases of SDLC. Okay, so this I'm talking about manual SDLC. So you can see the first manual SDLC, requirements gathering, system design. They will create sometimes some design, system design. It will include architecture, modules, interface, data, everything, and then they're gonna start implementation. They will start with the coding part. So you don't have to worry about the coding part as a DevOps engineer, because this will be the task of developer. Okay, coding part has been done, testing part will be started. Testing part has been done, deployment, that means installation in production. Or suppose if you want, like if you have created the delivery, like you have created this application, you can just hand over to the client that this application is ready, you can take this and you can use in your production environment. Okay, or if that team, that client do not have a specific IT team, what you have to go, you have to go for the client place, and you have to deploy this application or a website into the production environment, into their production environment. Okay, and there you have to monitor 24 by 7. You have to monitor, because monitoring is very important, because we will be able to catch the bugs. Okay, so you can see after deployment, the software will be used by end users. The software will be used by end user, that means customer. Just a second. Okay. Yeah. So the application what you have developed, you and your team, it will be used by end users. End users means customers. Whoever is using Flipkart website or Flipkart application, we call end users. If any issues or bugs are identified, they are fixed in that particular phase itself. Okay. So maintenance, now the last phase will be maintenance. So maintenance means what? Releasing the updates. enhancement, and if any bugs come, troubleshooting that bugs. Okay, and then documentation. Throughout the SDLC, documentation, like each and everything, they're gonna document that. It includes all the design documents, coding part document, user manuals, how to use this app, this website, what should be the mandatory files, everything, right? Now, review and evaluation. That means at each phase, the work will be reviewed by a team so that like they can make sure that everything is working perfectly. And then the last phase will be closure. Once the software is considered stable, the project will be closed. Okay, so this I talked about the this different phases. It is manual SDLC. Okay, the phases will be same in automated SDLC and manual SDLC also. Okay, so the first one is planning, then code, then testing. Okay, so let me make this plan, then code. Once code is written, it will go for build. What is build? I have discussed this in the very first class. Build means along with the application or the application, the website what you have created, what are the dependency files. They will they will keep all the dependencies files in a single package, application plus dependency file, so that if this application is installed in any Android phone or any laptop or any in like in any desktop, right, due to insufficient dependency, that person, that user should not get any type of error. So whenever that person installs Flipkart application, along with that application, dependencies will be installed, so that that person, that user will be able to use the Flipkart application properly. Okay, so once build is done, it will go for test, and once test is done, quality assurance check will be done. Okay, once quality assurance has been passed, it will go for deployment. It will go for deployment. Once deployment is done, it will go for monitoring, and the last phase will be maintenance. Any bugs, then it will be maintenance will be done, right? So this is normal SDLC. Normal SDLC means here, when my team or my project manager was they will be busy in discussing part, right, the developer will be sitting unless and until they confirm, then this developer will start writing the code. And once the developer has been involved in writing the code, the build team will be waiting for the developer to give the code. Similarly, the tester, they will be waiting for the build team to pass the code. Similarly, quality assurance team, they will be waiting for the tester to pass the code. That means each phase is dependent on the previous phase. Each phase was dependent on the previous phase. Okay, so this SDLC, this is known as manual SDLC, or you can call it as traditional approach, or you can call earlier what we used to have before 10 years ago. Okay, and the first thing, the first drawback, like everyone will be dependent on each other. Okay, the second one, suppose the code has been written by developer. Now build team will go and fetch the code, and they will start building the code. Now once build has been done, the test team will go and fetch the code. Okay, so every team, behind each phase there was a team, there was a set of people who will be doing this manually. This whole process was a manual process. This whole process was manual process. Okay, so first dependent, and the second one The drawback is this whole process was manual process. Okay. Third point is this whole, though each phase. So here planning, there is some sets of people. Coding, there are some sets of developer. Build, there are some sets of build team. Testing, for testing there will be some sets of tester. So each phase involves so many people, and still involving this many profiles, the duration will be too long. Duration was too long. Okay. And even the quality was not maintained properly. The quality of the software, the application. Why? Because this team was a different team, development team, and this team was a different team, operation teams. So if any bugs come here, suppose any bugs at the time of final deployment in the production, if any bugs come, they used to blame development team used to blame operation teams. There was no collaboration, there was no cooperation. There was no cooperation. So this was the drawback of manual SDLC. Now, this was all about manual SDLC. Now, automation or integrated SDLC, right? So yesterday itself, I have discussed the very first SDLC process was waterfall, right? So this is all about waterfall, where each phase will be dependent on the other phase, right? After this, agile method came. Okay. So let me, okay. So in agile, what happened? So this is manual SDLC. If we talk about agile, so here also same phases. Okay, this will remain constant. Okay, do not think that this phases will get changed. No, phases will be remain constants. The process of working will get changed and it will be automated. Okay, so now agile came. So agile means breaking, or you can call fragments, like breaking of this big project into small fragments, into small chunks. Okay, so this each fragment we call sprint. Each fragment we call sprint. Okay, and this whole process, that means breaking of the project into small sprints, that is called scrum. So when agile method came, the introduction of sprint and scrum came into the picture. So sprint means this small portion is a sprint. So each sprint, suppose this task. So let me show you. Let me go to this. Yes, so you can see agile method is an improvement of waterfall method. Here, the whole task will be divided into small fragments, and there will be continuously feedback with the client, and continuously feedback to the client. And if client suggests any type of suggestion, again implementing that or implementing in the project, and continuously deployment. Okay, so works on only development team, not development level. There is a term scrum in agile method. Okay, then if someone asks what is DevOps, so DevOps is nothing new but just a improvement of agile method. What is the improvement? I'm gonna tell you the difference. Okay, now we will understand agile method. Suppose you have received a project, and then this task will be divided into a small chunks. So you can see sprint 1 means here whoever will be handling sprint 1, they have to design login and logout interface. I'm talking about this interface. Okay, so that particular person has to take care of login and logout interface, user interface. Sprint 2, whoever will be handling sprint 2, okay, they have to design product images, they have to design catalog, they have to design price chart. Okay, so suppose if sprint 1, the task will be the very first task, he has to design login and logout user interface, right? So project manager will be like he will allocate some duration. Suppose login and logout should be, the task should be completed within 2 weeks. Okay, so this is sprint 1. Sprint 1, just a second guys, any doubt? All the tasks are done by, no, developers will have just a single task, that is to write the code. That's it. He has to write the code and he has to give the code. He has to forward that code to DevOps engineer. DevOps engineer will be the person who gonna take care of everything apart from coding. Okay, so this is right now I'm talking about coding part. Okay, so now the task has been divided into different fragments. Okay, the first sprint 1, similarly the second sprint 2. Here the project manager, let's see, develop, if I talk about developer, there will be not one developer, there will be a set of developers. It depends on company. If it's a startup company, there may be two developer. If it's MNC company, there can be 4 to 5 developer. Okay, so it depends on the project also, how big the project is. Okay, yeah, so you can see sprint 2, product image, catalog, price. Sprint 3, dashboard, my account, settings. Sprint 4, this cart, to design cart, then payment, then delivery status. Okay, so in this manner, task got divided among different developers. Okay, now why I'm telling this, because this is the method that has been adopted by agile. Okay, now let me have a new paint. Okay, now planning part has been done. Okay, developers started writing the code. Okay, so right now you can see there are sprint 4, there are 4 number of sprints. Suppose if I talk about, there are 4 number of developers and the task has been divided among 4 developers. Okay, now the first developer, the first developer, suppose there was 2 tasks in the first sprint, login and logout, right? He has to design login and logout is user interface. Now the first developer has designed the login, or suppose if we talk about, he has to write the coding part of suppose 6 number of pages, and the first number of page or first page of coding he has completed. So what he will do, he will push the code, right? He gonna push the code to central repository, central storage, right? Why he gonna push the code? Because whatever he has done, everyone should be able to view that. And if he will keep his whatever he has created, the coding part, if he gonna keep that in his laptop, how other team members will be able to see that, right? So he has to push that code to central storage. Okay, now as soon as As soon as the code has been pushed, what is the next step? The next step is build, right? So now this will be taken for the build, right? Now after build, this will go for test. This will go for test. Okay. Then once test is done, it will go for quality check. So till the time, this is the first page he has completed. First page he has completed, the coding part he has done. Page number 1, the whole coding part he has written. Okay. Now he forwarded that here. Page 1 he uploaded. And now this page 1 will go for the build and then test and then quality assurance. Meanwhile, the developer will also write page 2. Again he gonna push that page 2. So once here the page 1 got tested, everything is working fine. So page 1 will be forwarded for the deployment. Similarly, page 2 came, again page 2 will go for build, again test, again quality assurance. So this page 1 gone for deployment. Okay, deployment. Similarly, right now on the way it will be page number 2. Similarly, here page 3 got pushed by the developer, right? So similarly, we can assume that page number 3 is almost has been build has been passed. So in this manner the small fragments will get proceed, right? It will get proceed, and once all the chunks, all the sprints has been completed, so it will be the full project will be restored. Earlier what we used to do, earlier we used to sit unless and until the developer writes the full code. Full code means in designing this website from top to bottom, thousands number of pages. So you can assume if developer has to write thousand number of pages of code, he may take 2 months of time. So while developer was working, build team was sitting. They used to wait for the developer to pass those thousand pages of code, right? Then once coding part has been given, coding part, coding or code, this 1,000 page has been forwarded to build. Then build team used to start the packing or packaging of codes. That means here in earlier process we never used to add client, we never used to involve client, but here in integrated SDLC, suppose this developer has added the 1 2 3 page 4 and even page 5, he has added page 4 and also he has added page 5. Now page 1 got deployed, page 2 got deployed, page 3 got deployed, page 4 got deployed, page 5 got deployed. This whole user interface of login. Now login UI has been designed. Now client will be receiving the feedback. Client will be not feedback, client will get the notification that this user interface has been designed. Now once this is working fine, everything is good, this will be released in the production environment and this option will go live. Similarly, logout user interface or logout option will be designed. Similarly, the other things whatever we have discussed, product images. So one by one, client will be receiving the notification, client will have a tracking that till where the task has been reached. So I gave you the example of Zomato. If you're gonna order a pizza, right, you will get a tracking link, right? You can track the delivery person, that till which area he has approached, how much time it will take to deliver, right? Everything you will be able to track. Why? Because they are keeping customer in loop, so that customer will be able to know, yes, the delivery, the person, the item has been picked, the food has been picked from the restaurant, the delivery boy is on the way, he has reached HSR, he has approached Kormangla, he has approached this and that, right? So, what the same thing here also, whatever is getting completed or whatever, suppose if any error comes, even client will be able to get those notification also. Suppose in case here build get failed. So build get fail means the client will be getting the notification, and also here the developer will be getting the notification. Okay. Similarly, test got failed. There is some type of error. Even client will be get the notification, and even developer will get the notification. Okay. So here for each and every phase, we will be intimating client and we will be intimating developer, because developer is the person who has written the code. So he should be aware of each and everything unless and until everything is working fine. If any error is there, again, any error, suppose any error, like suppose let me make this a fresh one. So this was how we used to keep client and developer in a loop, right? Now, Agile is, it's not manual, it's a automated approach, right? So how the things is automated. Okay, so just a second. Plan, code, build, test, quality assurance, and then deploy. So guys, remember these phases. They like it like they may ask you, tell me the whole phases or explain me the SDLC process. Okay. Monitor, maintenance. Okay. Now the whole thing will be automated. How it will be automated? Planning done, code is getting ready, whatever the number of pages has been ready, it will be pushed to central storage, and in DevOps language we call this GitHub. Okay. And even the developer will have installed the Git software in their laptop. Developer will be installing Git software in their laptop. So what is Git software? You just assume this is local storage. Okay, what is Git? We're gonna see that in very detail. Okay, so this is local storage and this is remote storage, right? Do not ask why every time code has to be pushed. Code has to be pushed because everyone should be aware till which part the coding has been done. Okay, now page 1 completed, pushed to remote. Now from here, what do you think? who gonna take the code? Build team, like they will just log into this storage and they will fetch the code. No, this is not a manual approach, this is automated approach. So here integration tools, integration tool comes, and that is known as Jenkins. That is known as Jenkins. Okay, code has been pushed, Jenkins will pick the code and it will forward the code to build. Who is like behind the build? There is a team? No, there is no manual intervention, there is a tool. Maven is the software. See here, remote storage, GitHub is the software. For the building part, Maven is the tool. For the testing part, again we have automation testing, that is Selenium or even JUnit. There will be no manual testing, this whole process will be automated. Automated by what? We cannot automate the process by keeping human being, right? So suppose I gave you the example yesterday that if you want to have a chips factory, right? So first you have to prepare the chips and then you have to do the packing. But if it is a manual, like if it is a whole, the whole process will be manual process, it will not be possible for you guys to deliver a large quantity in the market. But to automate the whole process, you have to buy the machine, right? You have to buy a machinery. So as soon as the chips got prepared, what you will be doing, you will be adding those chips to inside the machinery, and machinery will start making the packets and adding the labeling and all those things, right? So if machinery or if tools or if software works, the chances of doing the error will be reduced to 0.01%. But if the whole thing will be done by the human, the chances of doing the mistake is increased, right? So here you will see the build tool will be Maven, the testing tool will be Selenium, JUnit, and then once the test has been done, the code will be forwarded for the quality check. And here also we will have a software checksum. Okay, so who is gonna take? So build, Jenkins will forward the code for the build. Once build is passed, Jenkins will take the codes back and it will forward the code for the testing. Once the test has been passed, Jenkins will forward the code for the quality check. Once the quality has been approved, Jenkins will forward the code for the deployment. That means who is the middle person? Jenkins. Okay, so this whatever the name I am taking, this is DevOps tools: GitHub, Jenkins, Maven, testing tools, checksum. This is a quality assurance. Now for deployment, who gonna deploy? The tools are there, like Chef, Puppet, Ansible. There are so many tools, it depends on company that what tool they are using. And even Kubernetes, or for automating the whole infrastructure, they can use Terraform. Even Docker, they can deploy on Docker containers. Okay, now once deployment has been done successfully, it will go for a monitoring. That means a monitoring part will be taken care either by DevOps tools, or if this whole thing is if this whole thing is implement on AWS, we have CloudWatch monitoring tool. AWS CloudWatch. Now for maintenance, if any bugs comes, now there will be set of people who will be fixing the bugs. Who will be fixing the bugs. Now tell me where you find manual intervention. Nowhere. Okay, nowhere. Earlier we used to have, see, developer will be remain there. We used to have build team, but right now there is no requirement of build team. Developer, DevOps engineer has to take care of everything. As an DevOps engineer, you have to take care of the thing that starts from here: build, test, quality assurance, deploy, monitor, maintenance. Maintenance you don't have to do. If any bugs and all anything comes, it will be intimated to developer, or there will be a maintenance crew. Okay. So as a DevOps engineer, so I told you that what you have to respond in roles and responsibilities. So you have to tell that I take care of automation. I ensure that there is a quality check. I am maintaining for the application that no, sorry. I ensure that there is a quality I am maintaining for the application. I ensure that I have set up continuous monitoring, and I have automated the testing process into the DevOps lifecycle. So this is how you introduce yourself. And if they talk about any tools, if they tell me the tools and technologies, right? So you have to tell that I am using GitHub Actions, or for the deployment of application onto the container. So this container orchestration is nothing but Kubernetes. I am using Kubernetes, or I am using configuration management tool using Ansible, or even it will be Chef Puppet. Infrastructure automation using Terraform. You can explain about all those things. Okay. So in roles and responsibility, interviewer, he will be asking you, tell me your roles and responsibilities. So first you have to always start from here: GitHub. Git, this is also one of the DevOps tools, important tools. GitHub, Git, Maven build tool. This you don't have to tell, because Selenium and JUnit, the software will be integrated. Thus, just you have to upload the code and test. Okay, so it's not necessary that you should have the idea. But I told you, DevOps is all about a culture. So whoever is a part of team, everyone should be aware of the whole process, right? I told you here. Let me show you. So you can see SDLC. So this is software development life cycle. This one. How we software development life cycle, that means life cycle, like the whole process, how we are delivering the software to the clients. So in an organization, even the developer will be knowing about all the phases. It's not like that the developer is writing the code, so he should be aware of that only. No, even the developer has to know about this all phases, because as a DevOps engineer, you will be sitting all together in a single team. In Agile, what was the drawback? In Agile, this all process was automated, but still there was two different team: development team, operations team. Still there was no collaboration. So DevOps came into the picture, and DevOps told, like DevOps, why there has to be two different team. All has to work together as a team. So now if we talk about if we talk about a team, in a team there will be project manager, there will be two, three developers, and there will be two or three DevOps engineer, and there can have some monitoring people. Anyhow, there is no need of monitoring, because the tools are tools. All the this software tools, like this Nagios, this all tools, whatever the DevOps tools we have studies, everything has replaced manpower. Like, there is no need of such a big manpower. If they can keep one person, that is enough. So because of this reason only, they are offering DevOps engineer a very high pay scale. Why? Because DevOps engineer is a person who will be taking care of all the phases. Where earlier we used to have thousand number of employees behind all those phases. Right now it will be just replaced by one or two or maximum five number of DevOps engineer. It depends on company. If you look for MNC company, there you will find maximum 4 to 5. Okay. So everyone has to know the phases. This is the common phases of software development life cycle. Okay. So we have seen what is manual, and this is integrated SDLC, or you can call automated SDLC. Everything has been replaced by automation tool. These are the automation tools. Okay, and this one was manual SDLC or traditional SDLC, what we used to follow before. You can call this waterfall method. So now Agile and DevOps is nothing but a same. In Agile, this is DevOps. A single team has to work, and Agile was still, though the whole process was automated, but there was still two different team. This is Agile. So DevOps is just an improved version of Agile. That's it. Here, just a single team. That's it. Okay. So this is operational team. This is development team. So this both got combined, and now dev plus OPS equals to DevOps. Okay, guys, any doubt? So we are very clear with SDLC. SDLC, waterfall, agile, and DevOps. So we can see automated integrated SDLC is a modern and efficient way to create computer programs or application. How? Using tools and technologies to automate the stages of SDLC. So, planning and designing will be the same phases, even the coding part will be also the same, but here the coders, they will be using advanced versions of the software, that is integrated development environments, so that the coding will be easier and more efficient manner. And then automated testing, then continuous integration and deployment, and then continuous monitoring and version control. So what is version control? We're gonna see that. Okay, then automated documentation, whatever is happening, everything is getting document. Okay, everything is getting recorded, each and every phases, everything will be getting documented. And also feedback loops, it will collect feedback from users and it will provide it to the development team. That means, suppose if any user is getting some issues or some errors, they will be approaching to the support team, right? And that the complaint, what they gonna note down or what they gonna record, that will be sent to the development team so that they can just come up with the better versions. Okay. So you can see, you like when you talk about agile, you have to mention about sprint and scrum. These two are very important terms. Okay, and even you can get this question: what is the difference between sprint and scrum? So you can tell sprint is nothing but a short time based period for the scrum team that works to complete a set amount of work. What is Scrum? A product is built in a series of repetition called sprint. It breaks down big complex project into bit-sized pieces. It makes projects more manageable. It allows teams to ship high quality, work faster, and more frequently. So this the whole process is known as Scrum. Okay, so you can see manual SDLC, everything was manually done, and now integration, which is the important tool. This is the important tool, Jenkins. Jenkins, you can assume this is a person who will be taking care forwarding the code here, or if any error comes. Suppose here build got failed. Now Jenkins gonna take back the code and it will push the code back to the remote repository. And also Jenkins will send the notification to the it will send the notification to the developers, and also it will send the notification to the client. So everything we have to integrate in Jenkins. There will be so many plugins. There will be so many software. Okay, so we have to add the plugins and we have to start doing the task. That's it. Okay, so we can see continuous development, plan and code, continuous test, build and test, continuous deployment, continuous monitoring, and now DevOps cycle comes. So you can see it will goes on. This cycle goes on unless and until the whole projects get completed. Plan, code, build, test, release, deploy, operate, monitor. So you can see a single team will be there. Okay. So now the next class we're gonna start the tool, and the first tool we're gonna start with GitHub and Git. And second, we will once this is done, we can move to Maven, or we can start Jenkins. So what are the tools we're gonna cover? First, we will be working on GitHub, Git, and then we will see about Jenkins because Jenkins is very important. Then we will be seeing about Maven, and then we have the important Docker, Ansible, Kubernetes, Terraform. Even we will be seeing about Nagios monitoring tool, SonarCube. We will be seeing about configuration management tool, Chef, and what else? Jenkins, Maven. See what is important. This is very important. This is important. In Jenkins, we have CI/CD pipeline. This is very important. This is a build tool. Docker is very important because the concept of containers come here. Containers. Okay. Ansible deployment tool. Kubernetes who gonna manage the containers. Terraform automating the whole infrastructure. Whole infrastructure, that is Terraform. Like I have covered cloud formation, right? Cloud formation in AWS. That means you have to add the template, you have to add the code, and server whatever the resources you need in AWS, everything will be created automatically, right? Same here, this Terraform. So cloud formation and Terraform differences: cloud formation will just work only with AWS, but Terraform is independent of the services. It is compatible with AWS, it is compatible with Azure, it is compatible with any of the cloud services. So all DevOps tools is compatible with any of the services. You can use these tools with AWS cloud also. You can use these tools with Azure cloud also. You can use these tools with GCP also. So nowhere you gonna get the bugs. This tools has been made in such a manner that it is compatible with every services. Okay. Now tell me guys any doubt you have, because the next class topic will be Git. Next class, Git. So I hope now we are very much aware of the topic. SDLC, DevOps, why DevOps, what is the use of DevOps, what was the manual approach, what is the current approach, or you can call modern approach, right? What is the difference between waterfall, what is the difference what is the difference between waterfall method and agile method, what is the difference between agile method and DevOps method. Okay, tell me guys any doubt you have. Yes, no, all clear, right?